Let's take a look at the definition about empirical probability. Empirical probability is based on observations obtained from probability experiments. The empirical probability of an event E is the relative frequency of an event. It's the relative frequency of event E. So PE gonna equals the frequency of event E divided by the total frequency. Okay. So let's take a look. So the empirical probability is defined what? It's defined from the probability experiment. And for an event E, so we're gonna use the frequency of event E divided by the total number of frequency. Okay, that's the formula. If we want to calculate the probability of event E, how to calculate? Find the number of frequency, okay? The frequency divided by the total frequency. And now, as we know before, the total number N can be the summation of all the frequency, okay? Now, let's take a look at an example. The first example is here. Book reading by US adults. Read no books. Okay, read no books. Huh? Oh. Oh, sorry. So read no books. 395. Read only print books. That is 578. And read, this guy is read only only digital books. Read both print and digital books. There are 426. Okay, so that's the pie part, a pie chart. So now I want to calculate what is the probability that the next adult surveyed read only print books during the last year. Okay, during the last year. So let's take a look this question. The question is read only print books. Okay, read only print books. As we can see, for this event, read only printed books is here. Is here, right? So based on the formula, the formula is what? Is the frequency of event E divided by the total frequency. So I have a question. What is total frequency for this guy? Any people know it? Including the students on the Zoom. Do you know it? What is the total frequency? How to calculate the total frequency?
You would just add it all up.
Good job. Good job. Just add all of them. Yeah, based on this guy, right? Just add all of them. So that's what I want. So I'm gonna add all the number. So for this guy, we have 578 plus 91 plus 406 plus 395. And this guy we're gonna give you 4090. Okay, 4090. And then we can follow the formula, right? The frequency of event E, here's the read only print box. That is 578, right? So we get these two numbers, and we plug in here. For the numerator is 578. For the denominator, gonna be the 4090. Okay, 4090. So we can calculate the probability read only print book. And this guy plugging in the formula, this is 578, okay, divided by the total frequency, that is 1490, okay? And you're gonna use your calculator and you The value for this guy going to be 0.388. Okay, so that's the answer. That's the answer. Now, I want to check how many students here. Okay. Now I'm gonna give you guys an question that you guys solve it. What is the probability that the next adult surveyed read both print and digital books? Okay, now try it by yourself. Okay, what is the probability that the next adult surveyed read only read both print and digital books? Okay, try this one for me. Guys, if you're on the Zoom, please type your full name, okay? Full name in the chat. So I can check your attendance because I find less and less students come to this classroom. So I have to check the attendance. Otherwise, some students may think, well, I just don't need the professor just don't care about the attendance. So I have to do the attendance. Okay. Did you finish it?
I think so.
What's your answer?
0.29.
0.29. That's right. Good job. Good job.
I don't know if I rounded too much or not.
Yep. For me, it's okay because I don't require you guys how many digits you're gonna put for the decimal. If the math lab, they will give you a specific requirement. They keep 2 digits or 3 digits.
Okay.
Yeah. So for these problems, I'm gonna write down the answer. Read both print and digital books. And we can check the event of read both print and digital books. Should be 426, right? The frequency of this event is 426. So we just use the formula 426 and divided by the total frequency, gonna be this guy, right? 1490. And the result gonna be 0.286. Okay, 0.286. Okay, so let's continue. I'm gonna give you guys another example. Oh, another question. What is the probability blah, 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 that the next adult surveyed read digital books? Okay, try this one. Read digital books. Be careful. Did you get it?
0.61.
Point what?
61.
Point
0.61. You said the probability of digital books? Is that
Yeah. Digital books.
Yeah, read on.
0.061.
0.061. That's wrong.
Wrong?
Yeah.
How is that wrong? 91 divided by 1490, huh?
No. Read digital books. Here is read only digital books, right?
Oh,
Oh, so you tricked us.
Of course, I need to check out you guys sleeping in the class, so I need to trick you a little bit.
But if it was just only, then we would have had it right.
Yeah, that's the question. I trick you.
You're tricking us. I have to watch you closer now.
Okay, Sam, do it again.
Okay, let me do it again.
.35.
Yeah, that's right. That's right. Good job. Okay, so I'm gonna write down this answer.
Yeah.
Let's take a look.
And like you said, it's okay if we round up after that.
Yeah, for me it's okay, but the my math statistics
Might tell you thousands or whatever. Okay.
Yeah. It depends the requirement from your my math statistics.
Okay.
Okay. So read digital books and be careful. I didn't say read only digital books. Okay. So for this frequency it should be 91 plus 426. Okay. Be careful. 426 divided by the total frequency. And this guy gonna give you about 0.347. Okay, that's it. That's it. Now let's move on. Another example. Let's take a look. Example 2. A company is conducting a phone survey of randomly selected individuals to determine the ages of social network. Site users. Okay, now I give you guys a table. Ages and frequency F. So 18 to 20, that is 156. 23 to 35, that is 312. 36 to 49 to 254. 50 to 64. 195, and the last one 65 and over The frequency is 58. Of course. Now, I want you guys to calculate what is the probability that the next user surveyed is 23 to 35 years old. Okay. Now let's take a look at this guy. So here is a survey of randomly selected individuals to determine the ages of social networking site users. And the first column is the ages. The second column correspondingly frequency. Okay. And the question is to calculate the probability about 23 to 35 years old. Okay. Now, based on the empirical probability formula, we know for the numerator, we're gonna find the frequency for this event, right? And we can check the table. The frequency for this event, 23 to 35 years, is what? Is here. 312, right?
Mm-hmm.
And now, what is the denominator? Denominator is total frequency, right?
So it'd be 975.
Wow, fantastic. Gonna be the
Oh, sorry.
summation of all this frequency. You're right. You're gonna get 975. I'm very glad I have a very smart student. You did a very good job. Okay, so now we can plug in, right? We can plug in 23 to 35 years. For the numerator, that's the frequency for this event. That is 312 divided by the total frequency, gonna be 975. And you're gonna get what?
0.32.
Good job. Good job. 0.32. Now I'm gonna give you guys a question. Let you guys try it. What is the probability that blah 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 is 36 to 49 years old? Okay, try this one for me. Okay, I think you guys should get it very quickly, right? So this is a very beautiful word question. Now let's take a look. So for this event, we know that the event is between 36 to 49. So the numerator, we're going to check the frequency for this event. And we check the table, that is 254. And the total frequency going to be 975. And this guy going to give you the
0.2.
26, right? 26. Now, let's try another one. What is the probability that blah, 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 on the age 36? Okay.
.48.
What?
0.48.
I think you make a mistake.
Under the 8500,
Yeah,
so 312 plus 156.
that's right.
Huh?
That's right.
Is that right?
Mm-hmm.
Okay. So when I divide it by 975,
You got what? You don't need to put in the percentage. Give me the 3 decimals. How much you got?
do what?
What's the value you got? Oh, I make a mistake maybe.
That's why we're like, wait, what are you doing?
Let me check the answer. Oh, 0.48.
Yeah.
Oh, you are right. You are right.
I was like, wait, what? You
Let's
said
check
all-
the other province. So give me a different number. Okay, that's right. That's
I
right.
Okay.
couldn't figure out why I was wrong because that's what I got too. I
Me
was
too.
like,
I was like, wait a minute, hold on.
I was trying to figure it out what else I could do here.
Me too.
Okay, you did a very good job. Very good job. Okay, fantastic.
We got you get there.
So the probability on the age 36 should be what? Should be 62, right? 62. 156 plus 312 divided by the total number.
So it'd be
And this guy we're
460.
gonna 468 divided by 975. And it's about 0.48. All right, good job, good job. Okay, now the last one. What is the probability that is above 22, the age 22?
Oh,
I'll try this one, okay?
okay.
Did you get it?
I think so.
What's your
I
answer?
got 0.16.
1/6.
Yes.
0.84 is what I
Zero
got.
point 0.84. That's right.
Okay, so what did I do wrong here? Above.
Above.
Oh, okay.
Start again. 1 more minute.
Hold up. Oh, okay, I see what I did. I totally went below. Oh my gosh. Okay, I got 0.84 also.
Great, great. Okay, I'm gonna write down the answer on board. So be careful here. Is above the age 22. So above the age 22. So we're gonna check the table above the age 22. It's gonna be 23 to 35. Also include all these column, right? Except this value. So we're gonna add all these value together, and we're gonna add all of them. And the denominator gonna be 975. If we add it together, you're gonna get 819. And divided by 975, you're gonna get 0.84. Okay, 0.84. That's it. Okay. Do you guys have any questions so far? Do you want more examples or just move on? Okay, great. Let's move on. Now I'm gonna talk a little bit about the properties of probabilities. What kind of application for the probability? So let's take a look. The first rule of the probability. The range of probability rule. Okay. The probability of an event E is between 0 and 1 inclusive. Inclusive, that means include 0 and 1. That is, the first one is what? The first one, the probability always positive or non-negative. Okay, always non-negative. And the second thing is probability is always between 0 and 1. Okay. In reality, if you see a probability is negative, that's ridiculous. Probability never be negative. Okay. Another thing is if a probability is 2, somebody tells you the probability of something is 2, you shouldn't trust that guy because probability never greater than 1. Okay, one means what? One means that event can certainly occur, 100% gonna occur. So let's take a look. This picture gonna help you guys to understand the application of probability. Zero and 1. If probability equals 0, that means impossible. If probability is 0.25, unlikely. Okay, unlikely. If probability is 0.5, that means we have even chance. Okay, even chance. If probability is 0.75, that is likely. And if probability is 1, that means that event gonna happens, definitely happens. Okay, so I just want to give you guys rough idea what's the meaning of the probability for a specific value. So if a probability equals 0, that thing couldn't happen. Okay, impossible. If some event give you the probability equals around 0.25, that means that event is unlikely to occur. And if a probability is 0.5, just like use toss a coin, that we have 50% even chance, right? When you toss a coin, you probably you have 50% to get a head or tail, right? A head or tail. So even chance. And if the probability is greater than or equal to 0.75, that means that event is likely to happen. If probability equal to 1, that means that event definitely gonna happen. Okay, so a good example is about the election, president election in this country. A lot of news, they do some poll, right? Now the Biden probably has a little bit higher support rates. They do the poll than the Donald Trump. For example, now if you do, if the Biden has like 65% support rate, and the Donald Trump has 35% support rate. So you can tell from this picture, the Biden probably is likely to become the United States president. Okay, but you never know in the future, right? The poll always changes. Probably go to the November, the poll totally changes. They just go to Donald Trump, and Donald Trump gets over 0.75, for example, and he definitely will be high likely to get re-elected. Okay, so that's the application for the probability. Okay. Okay, now let's see another one. Definition. The complement of event E the set of the set of all outcomes in a sample space that not included in event E, okay, not included in event E. Okay, so usually we denote the complement of event E as E prime. Okay, E prime, and this guy is, be careful, is not included in event E. So we can draw a picture. Okay, we can draw a picture. So we have a picture, and this picture we say, hey, inside of this rectangle area, we call it sample space. Okay, sample space. Sample space, and of course, we have a sample that we use a circle to represent the event E. Okay, event E. How about the complement of event E or E prime? That means the shaded places. Okay, by definition, that is E prime. Prime. Okay. You see it? Okay. We are not included in event E, so the left place is gonna be the E prime by definition. Okay. Now I have following properties for the E prime. PE plus PE prime equals what? Do you know? Can you guess? The probability of E plus the probability of E prime, that equals the whole places, right? Gonna be 1. Okay, 1 means what? Means certainly. Okay, gonna happen. Okay, certainly gonna happen. If probability equals 1. So if you included all the sample space, okay, that means that event definitely gonna happen. Okay, because you include everything. And of course, some people would like to write down is this way. How to find the probability of E prime? We just let E1 minus PE. Okay, just move this term to the right-hand side or subtract PE for both sides. Okay, you got this guy. Okay, now let's take a look. An example. And through this example, I'm gonna teach you guys how to use this property. Okay, we're gonna still use the example we learned. Okay, we're gonna still use this table. And the question is, what is I'd like to write down another page. Use this table. Find the probability of randomly selected social networking site user who is not 23 to 35 years old. Okay, if we assume E is the event 23 to 35 years old, right? Now, I want you guys calculate the probability that is not 23 and to 35 years old. Still, we're gonna use the table. Okay, try it by yourself firstly. Okay. Now I'm gonna write down the answer on board. Okay. Of course, you can use the older method. Not 23 to 35 years old. So just exclude this frequency and let all this frequency added together, then divided by this total number. Okay. However, since we learned the complement of event E, so here is not, that means E prime, right? E prime, not 23 to 35 years old. So based on the formula, how to find the probability of PE prime gonna be a 1 minus or 1 subtract PE, right? What is a PE? PE is the age between 23 and 35, right? So we can calculate the PE is based on this table. Is on the table. PE is 23 to 35. From 23 to 35, that is 312 divided by the total number. Okay, and this guy gonna give you 0.32, right? Now you can calculate E prime. Gonna be 1 minus PE. So it should be 1 minus 0.32, and that guy gonna give you 0.68. Okay, that's it. Or you can use the method we learned from previous one, right? The method we learned from previous, if not, that means we're gonna add this guy, this guy, this guy, this guy, right? Then divided by 975. You're gonna get the same value or the same answer. But here I want you guys to use the property of complement. Okay, I want you guys to use the property of complement, this formula. Okay, now, and I'm gonna give you guys an example. Find the probability blah, 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 who is not 18 to 35 years old. Oh, sorry. Find the probability, blah, 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 who is not, okay, not 18 to 35 years old. Now, I want you guys use the complement, use this formula to calculate this probability, okay? Try it. Okay, I'm gonna finish this problem together. Okay, so if we let E is what? E is 18 to 35 years old. All right. Now, what is E prime? Not. Okay. Then what is PE? PE is 18 to 35 years old. Okay. So we can see from the table, 18 to 35 years old, going to be these two numbers. We add these two numbers, right? We add these two numbers. And divided by the total frequency, going to be 975. And this guy going to give you 0.48. Okay. Now, probability of E prime going to be 1 minus PE. 1 minus 0.48 equals 0.52. That's it. Okay. I'm gonna wrap it up class here. Thank you for coming. Have a nice day. Please finish your homework 3. Okay.
Question.
Question. Go ahead.
When will we find out what we made on our test? Is it posted already? Will it post or?
Oh yeah. Sorry guys. Yes, I'm gonna post all your grades on your Moodle.
Okay, perfect.
On your Moodle. Okay.
Okay, thank you.
You're welcome. Hi, could you come here and type your name here? So I can put everybody's name. And it will be much more convenient for I to check for your name.
Just on the, where it's at on here? Oh, just right here.
No, right here. So I can check my computer. All your names will be here.
Why won't this let me leave? Okay.
I think she's got to click out of it. She don't want to leave.